you might actually not need to go native, guys. If you've been tossing up between native and progressive web app, or building a native or a progressive web app, hopefully I can clarify some things, and then we'll dive in and I'll configure a basic progressive web app from scratch. So before we start, a little bit about me. My name's Jack Kranz. I'm a software architect here at SSW, and I've done a lot of native iOS and Android development, and naturally I got interested in some cross-platform solutions like Xamarin Forms, React Native, and Flutter, because it means less work for me as a developer. And I've also done a lot of just standard React work, as well as run some React training courses. So you notice my Twitter's on the bottom there. If you want to get in touch with me, ping me there. So you're probably wondering, if I have a lot of native app development experience, why I went down the road of a progressive web app. So I'm going to tell you a little story about how that all happened. I was working for a client and we started building a React app for them. We'd probably been going about, 2 weeks or so, and they decided, hey, we want it to be a mobile app as well. And we thought, cool, we'll just make it responsive for mobile. We'll make the website responsive and it will work. And then they said, no, we want it to be installed and downloaded on the user's phone. So then naturally I thought, great, I've done some native apps before, so let's do an iOS app, let's do an Android app. Obviously, what happens there is it costs them a lot more money to actually get up and running, because they've got to build and maintain 3 solutions now. So then we went down the road of progressive web apps, and I started researching into them, and I've never looked at them before. But before I knew it, I was this guy. So the reason I was this guy was essentially I learnt about some game-changing browser features that are only available on most mobile devices now. Even though Google's been pushing progressive web apps for years, Apple only really caught up in the last year or 2 years or so. So I'm going to tell you about what are, in my opinion, the 2 biggest game-changing features that allow web developers to really blur the lines between a native app and a website. So game changer number 1, your website can actually be connection independent. You can have the entire thing running offline. Users can make data changes offline, and you can synchronize those data changes when they reconnect to the internet. And you can even cache your entire website or web app offline. And ultimately, it's an instant boost in user experience, and that's what we found. As soon as you get rid of this guy, users are really happy. So highly recommend, even if you're not going to build a progressive web app, you can implement these features I'm going to tell you about to manage the offline experience for your users. And this was actually super important for us. We were building an app that needed to run in a mine, and a pretty deep mine, so they didn't have internet access. And our progressive web app allowed them to still make data changes and use the application even when they were down there. So really cool. And essentially you really get the choice to choose how that offline experience works, whether or not they just have a little status bar at the top that says online or offline, or like a lot of websites you might have seen do, you can have a little spinner that says reconnecting until they're trying to reconnect. So, or maybe you don't even tell them they're offline and you just handle that in the background. So that's game changer 1. Number 2 is you can install your web app now. So instead of just accessing it through the browser, and you've got the address bar at the top, you can have it installed on a user's device. They have an icon on their home screen, which I'll show you later. And on some devices, they get a little prompt like this. On Android devices, they'll get a little prompt like that, prompting them to add the progressive web app to their home screen. And here actually is the name of your progressive web app. So this demo here is just called PWA, and the icon is PWA, the PWA logo. But you can pretty much make this whatever you want. And I can probably show you an example now if you want. I'll just grab my phone quickly. So Twitter actually has a PWA. So if I jump onto the Twitter website, let me just connect the phone. And I should be able to share my screen with you. Awesome. So I'm on the Twitter website in Safari, and I can actually add this to my home screen by clicking down here, which is called the action sheet, scrolling down, and there's an add to home screen button. If I do that, I've done it a few times, as you can see, but this bottom one is the most recent one. Just wanted to demo this little feature. So that's the PWA I just installed, and you'll see we don't have an address bar at the top. If I double tap to go onto my app switcher, I can close it, and it runs separately from Safari. And I believe I have the native Twitter app on here as well, probably the top one. That's also a progressive web app. See, it's even hard to tell. Yeah, there we go. So there's the native one. And yeah, you see, that even takes a little bit longer to load in some cases. But it'll run separately from the native app. So I've just gone back in, and you can see I have 2 instances of that running. So another good way to actually let your user install an app a second time on the device. They can have multiple versions running with different accounts logged in if you don't want to have to handle that yourself. So that's another good little use case for you. But anyway, that's a little bit about how to install it on an iPhone, and obviously you get that nice little prompt if you're on an Android phone. What we're going to do tonight is I'll tell you about why you should build a progressive web app if you're not already convinced based on those game changes, and I'll go over how I choose when to build a PWA or when to go native, and cover some interesting or useful tools. And then we're actually going to get started on developing one. So I'll tell you what the main ingredients are, and then we'll go into a code demo and configure a progressive web app from scratch. So why should you build one? Apart from it being offline and installable, you can build your progressive web app once, similar to those cross-platform solutions. Instead of having to deploy for iOS and Android, bundle it up, send it off to the App Store for packaging, that kind of stuff. Now you can build it once and run it almost anywhere. And the great thing about that is it also means you can develop it anywhere that you can develop a website. So I can develop on my Mac, I can develop on my PC, and I don't need to buy an iPhone and an Android device to test on necessarily. I can use my phone, and it really cuts down the barriers to entry. So it's cheaper as well in that respect. So you can run on your phone, on your desktop, and believe it or not, some fridges can run progressive web apps. This fridge is running Android as well, but you know, I don't know anyone that has one. Anyone got one of these smart fridges? Adam does? Oh, cool. Okay. Awesome. So as well as being easy to build and set up, deploying is really easy. You deploy it like you deploy a normal website. So you can have it as part of your pipeline and push it up to a static site. And that essentially means updates are super easy, bug fixes are easy, and you can say goodbye to these guys. Yeah, so it's essentially a normal website with a few little features added in that allow you to add to the home screen. So we're going to cover that. Just a quick little rundown. Native and cross-platform. Different builds for each device. They're distributed through the App and Play Store, and it means the updates require an install versus progressive web app updates. You can actually choose exactly what that update journey looks like for your user. Just like you can choose what the offline experience looks like, you can determine what the update journey is like. So maybe you want only the new assets to be loaded. Maybe you want the entire thing to be fresh every time they access it, or anywhere in between. And yeah, native app can be more expensive. So these are the 3 main reasons I think you should consider when choosing to go native or build a PWA. But obviously there are some times when a PWA won't cut it and you have to go native. And I'm going to run through when those times are and how I figure that out, essentially. So when do I choose to go native? When there's a requirement for device hardware features. Even though the web can do quite a lot, there's a bit of disparity between devices. So some devices, like a lot of iPhones, can't access certain hardware features that Android devices can, and some both Android and iPhone devices can't access certain hardware features like NFC, that kind of thing, Bluetooth. So there's a lot of them, and I'll show you how to figure out what your device can handle and what you can actually put into your web app. And yeah, features aren't supported. Unfortunately, push notifications aren't there yet on iOS. They're there on Android. We'll get there hopefully. So these are some of the sites I actually use to figure this stuff out. This one's really good, whatwebcando.today. If you jump on here, it'll tell you what your current browser can actually access. So if you jump on here on your phone, and your iPhone or your Android device, you'll notice that, yeah, certain browser features aren't available. As it happens, this computer, the Chrome on this computer can access a fair few features, but yeah, that's going to differ. But the best way to actually figure this out is caniuse.com. Hopefully some of you know this, but essentially, if I know what the JavaScript or browser feature is that I'm trying to access, I can type it in here. And for example, service worker, got to spell it right. And then I get a nice little graph telling me which versions are supported. But essentially, you're looking for iOS Safari, an Android browser, or Chrome for Android. And I might say camera. And it will tell me where I can get camera permission. So yeah, very useful just to make that decision before you go down the path of developing something, so you know what you can and can't use. All right, so that's how I make the decision when to go native. Another thing worth mentioning is if you're developing an app that's for a very specific use case, for a very specific company, and maybe they want to only distribute that to people that are employed there. I know through Apple, you'll need to enroll in the Enterprise Developer Program and roll out your app that way, maybe through a mobile device management setup. With PWA, you can even have your app hosted on premises, and they can just access a link on your Wi-Fi to download it. So that's going to be really good as well. And that's exactly what my client did with theirs. All right, so that's when I choose to go native, or how I choose to go native. Now I'm going to tell you about the two main ingredients to a progressive web app. Firstly, we've got our manifest.json or web app manifest, and we've got a service worker. And you also need to make sure you're serving on HTTPS. I didn't include that as one of the ingredients because hopefully all your sites are served on HTTPS. But yeah, definitely keep that in mind for those on-prem times. You might need to self-sign a certificate or something like that. All right, so what's a web app manifest? So it's a JSON file. You could probably tell by the icon there. And it just provides us with some info about your app, provides the browser with info about your app. And that's how it knows what to call it in that prompt and how to install it. So here's an example of one. There are plenty of fields you can add. This is just a pretty basic one. You've got a short name at the top and then a name below that. The short name is what the device is going to show if the full name or the normal name below doesn't actually fit into the display port. And then, so you can specify your icons on there as well, and you can put in a whole bunch of different sizes. I've just got two here, but depending on device, the devices you want to support, you can get different sizes in there. There are tools to generate them, so you pass in a high-res icon and you can generate those. As well as that, you've got start URL. So essentially, when they do close your application from the app switcher and they reopen, where does it open to? Generally, you'll just put that as the root, but it really depends where you want to go. And then you've got background color. So if you don't give them a launch a launch screen icon, or the launch screen you give the web app manifest doesn't actually fill up the entire viewport of the device, this is the color that will be filled in the background. And then you choose display mode. So that's really important for blurring those lines between the PWA and your web app. This tells the phone how to actually render that web app on screen. So standalone, you'll get a display like the one you saw on the Twitter app before, where there's a little status bar at the top, but it doesn't look like a browser. You can get it to render like a browser as well, if I don't know why you would. And you can also remove the top status bar by specifying full screen mode. And then you've also got scope and theme color. Scope essentially defines all the URLs that are within your application scope. So if they click on a link, the phone knows whether or not to open up an external web view or to actually open up the link inside your app. And finally, theme color, and that's just what color is the status bar at the top if you're in standalone mode. All right, so that's a manifest, and we'll go through creating one or just how to link one to your app a bit later. What's a service worker? The second ingredient. So a service worker is a piece of JavaScript, and it sits in between your web page and your web server or the internet, and you configure it so every time your web page wants to request something from the internet, it has to go through the service worker. And at that point, the service worker can choose to do something to it and then send it through to the web server. And it can do the same on the way back. So when the request is returned, you can do something to it and send it back to your web page. But I've been talking a lot about offline caching and syncing. So of course, your service worker can talk to the cache at any point in this story. So you might choose to completely skip going to the internet and just use the cache, or anywhere in between, depending on what the request is. So I'm going to quickly cover the life cycle of a service worker, and then we'll go into a demo. We'll build one. Essentially, when you don't have one, there's no service worker, then your browser will install it. If there's no errors in your code, it'll go into an activated state, and then it will sit in an idle state until a fetch request or a message comes through. A message is another API we use to communicate between the service worker and any code running in our web app. Because they are running on separate threads, we can't directly interact with them, so we use this message API. And if you navigate to a different page, your service worker will become terminated and then reactivate and go back into that idle state when you get back into the app. Cool. So let's jump into the demo. What we're going to cover in the demo is I'll show you a basic web app I have and how to make it installable. We're then going to cover testing on your mobile device, or how to actually get your PWA running on your mobile device from your local machine. We'll look at caching and different caching strategies you can use. And we'll handle some offline data changes. And then we'll look at persisting them. Cool, so I've got a basic web app configured here. Let me just close some of these folders. And I'm just going to start it up. So I've got a little, it helps to have that running, doesn't it? Give me a sec. So I've got a little Express server here that will just host our application. Yeah, sure, sorry. I've got a little Express server here. Don't worry about this too much. It's essentially just allowing me to host the application and spinning up a dummy endpoint so I can get some notes and then push a new note. But yeah, don't worry about it too much because that's not what we're talking about here. I'm just going to start that up now. Cool. We're on port 3001. And let's just jump over into Chrome. All right, here's my web app. And I can load those notes I was talking about. Might increase the size of that as well. Can add a new note. And that's basically what it is at this point. But if I take my browser offline, try to load a note, load the notes, add a note, I'll get an error here. And then if I try to refresh the page, there's our little dinosaur. So yeah, I do love the game, but let's look at firstly installing it, and then we'll look at getting it to run while you're offline. Cool, so jumping back into the code, the first thing we need to do is just jump into this app folder, and you'll see I've got a manifest.json. Can everyone see that okay?
Zoom in.
Yeah, I will. And I'll probably get rid of some of this stuff. All right, so very basic. I've got my name at the top, my start URL, little description. So depending on the device, description might be displayed when you're installing it. And then, yeah, icons like I said earlier. And we can also just pass in the orientation. However, only portraits supported on iOS at the moment, so it's not super important to cover. Let's link that into our app. So I'm going to my index.html, and then all we need to do to link that is add this line here, which will allow us to specify the URL of the manifest. And an important thing to add, this on line 7, we've got Apple Touch icon. So Apple decided to be really different again and ignore all the icons you specify in your manifest. So if you need to display a specific icon on an iPhone or an iPad, you'll have to pass it in here. All right, so let's save that. And I'm just gonna check that our, yeah, still running. Jump back to Chrome, refresh, and you'll see that manifest has come through on the side here. And if I go over to the application tab and to my manifest, Chrome has picked up some of the information about my app from there. And I've just put a different icon here just to demonstrate that you can put whatever you want. So you could have different icons for different screen sizes. It's not being generated from the same file. So there we are. But you'll notice that we're missing the second ingredient. Chrome is really nice and tells us that we have no service worker detected. So let's actually fix this error message. Gonna jump back over to the code. And there's a couple of things we want to do. Firstly, you need a service worker file. I've just got this one here, sw.js. Then I'm going to go into my application file and register the service worker with the app. All the rest of this code here is just code to actually get that functionality to happen. It's written in vanilla JavaScript just to prove to you that all this stuff we're doing is framework agnostic, but I'd usually go for React or something like that. All right, so let's get in our register event. So we've got a function called register, and we specify the path relative to this file, and then we can have some logic if the registration fails or just after the registration happens. And you can also get some data from that registration, for example, the scope. One more thing we need to do is hook into an event to actually load that or to actually call that register. So I've just added this event list now load, and I've called register from there. And a nice little thing to do is to add this line, because if the user's browser isn't supporting Service Worker, it just means it's one less thing one less error they have to deal with and you have to deal with. All right, let's save that. Jump back in, refresh, and if I go to Service Worker, you'll see that our Service Worker has been received, and I'll jump over to my console, and our Service Worker has been successfully registered at that scope. But if I jump back over to application, you'll see that the page doesn't actually work offline yet. So what we need to do to get that to happen is to hook into that fetch event and get some logic happening. I'm going to jump back over to the Service Worker file, which you'll note is empty. And we're going to hook into some of those lifecycle events that I mentioned in the Service Worker lifecycle, and you can hook into all of them. So we're going to start with the install event, and here we're just going to log it. And then we'll also hook into the activate event. And this little piece of code in here is really nice if you're running your app on browsers. This means that when the Service Worker activates, it will then take control of any other tabs the user has open in their browser that are running on within your application scope. So if you push out a new version of your Service Worker, it means there's only one running at any time on the user's device. So good little piece of code to have in there. All right, so let's add in our fetch there. Save again. You'll notice it's not doing anything again. We're just going to log that the request is happening. And if I load notes, one little tidbit I forgot to mention. Go back into Service Workers. You'll see that Service Worker 11 was activated. That was the one we had previously running, the empty one. But number 12 is waiting to activate. So it usually won't activate until the next time the user browses the site or opens up the app. When you're testing, you can skip waiting and get it to activate immediately. And then if I load, you'll see that that fetch event is getting called in the Service Worker. All right, so at this point, we can actually make our app installable. If you see, let's just load it up again. Get this little install option up here, and I can install my progressive web app. And then it's actually opened up in a separate window on my phone here, on my computer, and it's running standalone. But I've been talking a lot about getting your app to run on your mobile device. So why don't I show you how that looks as well? So there's a tool I like to use for that. Just opening up a terminal window, and I'll increase the size for you. There's a great tool called ngrok or ngrok, and it allows me to create a tunnel a web tunnel from my local host to the internet. So it basically allows me to have a public URL for my local host, and that has been the most reliable way for me to test my PWAs. So really easy to set up. Just type ngrok, and then we're going to specify our port number. And you'll see it gives us 2 URLs here. Most importantly, one with HTTPS. So when your web app is a local host, you don't need to have it working on HTTPS, but if you're running it anywhere else, in order for the Service Worker to be activated and in order for the manifest.json to be picked up, you'll need to have HTTPS. So why don't I see if I can demo installing this one. Just going to go over there. And I've just clicked on handoff, but that's not what we need. What I actually need is this URL. So I'm just going to go back to close the web app, go back to my browser and go to that ngrok URL. And then, you can type it manually, but handoff's a really good feature. So there's the web app, and we'll go and add it to the home screen again. And usually takes a sec to pick up the icon, but there we go. And again, you can see I've done this before. That's an old one. Here's the latest one. And there we go. Works the same. And now it's running on my device. Cool, so that's how you get it running on your device. That's how you get it to an installable state, but it's not doing anything too amazing at this point. So why don't we try setting up some caching logic to cache the entire thing offline. Before we do that, I'm going to cover some caching strategies, and I'll show you examples of these. There's many different caching strategies, but the first one we're going to cover is cache first. Essentially, it is what it sounds like when your page makes a request to the service worker. The service worker will hit up the cache first. If that fails, it'll then go to the network and come back. But if the cache has the file you're looking for, it'll just go straight back to the page. So let's do that. I like to do my caching in the install event. So I'm gonna change that. And here I've got v2 of my install event. And essentially we're gonna just open up my cache, which you have to specify a name for. And then we'll use this cache API to add everything from our cache manifest. And our cache manifest is essentially just, an array specifying the files that we want to cache. So there's ways you can configure your build setup to actually generate this when you build using Webpack, that kind of thing. I won't cover that in this talk, but it's worth noting. But a lot of people will just put every single file from their app here. All right. And we'll also need to modify the fetch event to respond with the cached item. So let's go down here. That's v2 of cache first. Let's just go v1 first. So essentially here, we're going to see if we can match the request in the cache, and then we'll return that. Otherwise, we're going to run a normal fetch and just fetch it from the web. So let's give that a quick go. And I'll jump back over here, and we'll see that my new service worker is installed. And let's refresh. Why don't we just run the local host? Could be a bit faster. And you'll see that the cache is opened and those items now have been cached. So if I take my app offline and refresh, our cache has just responded with those Usually you don't get that flicker of the dinosaur. Not sure what happened there. Don't worry. I have never really had that occur, but you'll see here our most recent requests. Chrome actually tells us that they came from the service worker. And it looks like Bootstrap came from the disk cache, which is great. And this would be the same on our mobile device. The only issue you might have noticed with the cache first is once we've cached the data, we need to either recache that with a new version of the service worker, or we don't get any of the updates to the web app. So if I jump back over to the code, go into my index and update something, I'm not actually getting those new versions coming through, and you'll notice the cache isn't actually opening up. Not getting that cache open message. And if I say go, I'm still offline, so that probably helps to go online. Let's do that quickly. But you see the cache still isn't opening up. Just going to take us offline again. And another tidbit is, because we're only running the cache logic in the install event, any new things coming through, like notes, for example, notes work online, go offline, notes don't work because we didn't cache that new request. So one of the best ways to deal with that, we'll jump back over into our service worker file, and I'm going to show you cache first v2, which is essentially just going to do the same thing at first, except once our fetch comes back from the net or from our server, we'll clone the response, open up the cache, and put our request in there. So this is going to cache anything new. And then I can load my notes. Oh, I didn't install the new version of my service worker. Remember to do that. What we can actually do is hit update on reload, which means every time I refresh the page and I'm online, it'll pull in a new version of my service worker for me. So that's a little quality of life improvement for you. Let's load those notes, go offline, refresh, and I can load those notes offline now because the new request was cached. All right, so now we're going to cover probably one of the most useful caching strategies, network first. And you guessed it, it's cache first, but in reverse. So I'll show you a little example of what that code looks like and demo it quickly. So here, I've just encapsulated that cache response code from earlier into a little function so I can fit everything else on the screen. And yeah, we're just going to fire off that fetch request, cache the response after, and if the fetch request fails, we'll match from the caches. This is just one implementation of it. You really have the service worker really gives you as a dev the choice to kind of do whatever you want here. So you might actually hook into navigator.online and check if they're online first and then run that logic. I like the failover method, so we always try to get the freshest data first. And let's give that a quick go. Go back online. So my new version's running. Boom. And if I jump in and make a change, it comes in immediately, so we're fresh in the latest content, which is really good. And yeah, you might want to avoid caching all the GET requests for data. That kind of stuff you probably want fresh, obviously. All right, So the whole story around getting the fresh content, not getting the fresh content brings up an interesting point. And that is, how do we go about updating our cache and updating our app? There are a few ways to do this to control your update story. You can invalidate the entire cache just by changing that cache name in your service worker. So that's probably the best way. If a brand new version comes out and you don't want any old data to be there, you can do that. And you can also do what I call whitelisting, and you can recache some files in your install method and whitelist certain ones. I'll show an example of what that code looks like. And this is great if you've updated the logic of your app, but the assets are still the same. You might have all those assets in the whitelist. We've hooked into the activate event here. And we've just got a list of whitelist files here. I'm just going to whitelist the root. Doesn't matter what we do. Yeah, it's up to you. Well, it does matter, but it's totally up to you, is what I mean. And if our whitelisted file is not in there, not in the cache already, we're going to delete it. Alternatively, change the cache name. And you know what I might do? I might actually just pass in my CSS here instead. Go back quickly. Oh yeah, so just going to go into application and my local storage here. Sorry, be my cache storage. And you'll see that I've got new cache data there instead of the old stuff. All right. So that's a little bit about how do you control that update story, but ultimately you have the tools to change it however you want using these particular methods. So now we're going to look at handling our offline data changes and how to do that offline online sync. And again, there's a ton of ways you could do it. We're going to look at the message API to send a message to your application from your service worker when a request fails, and then we'll store that somewhere. And then we'll cache it in our application. And let's have a look at how that works. So we're going to cache our post messages because we want them to actually be stored offline until the user reconnects. So I'm going to go down to my fetch event. So now, this part here you'll notice is the same as before, except if my method is post, we're going to clone it. And then we're going to post a message to our service worker. You might be wondering what this code here is. This is just checking if we're posting the message to the tab that's in focus. It's not super important for mobile because hopefully they only have one version of the app, but this is how to manage various versions of the app running on the same device. Cool, so now we've set up how that post request or that post message here. Let's actually go in and go to our client and hook in. And it's as simple as just hooking into a message event listener. And you'll see that I'm just going to log the data and the body coming through from the event there. Let's give that a quick go. So we're offline, gonna load some notes. Gonna Hang on a sec. Let me just refresh. It's interesting. They should be added to my offline storage. So sometimes when you have the same window running in localhost and you have your tab offline, Chrome, I've noticed, sometimes resets the online offline status. So I'm just going to go and open up a new tab. So you're not going crazy when stuff like this happens. It's just Chrome trying to be helpful. I'm going to take it offline. Should be able to load our notes. We've never actually made that load notes request since we invalidated our cache. So now we have notes sitting over here in the cache. And yeah, you'll see I actually get that error message. The note's not doing anything. So let's just chuck in some logic to handle that. This is one way to do it, and I'll show you a second way. So I'm just going to call my add offline note method, which is going to push to my offline notes array and re-render the notes. All right, we've got a new version now. Adding notes offline. Let's go back online. So that's refresh. And I had 5 notes, or notes went up to number 5 before, and I don't have any more there because those offline notes were only stored in the application memory. As soon as I refresh, they're gone. Let's look at handling that a different way. All right, so what I'm going to do here is just use local storage to save my notes. You can use IndexedDB directly from your service worker if you want, if you don't want to use this message API, or you can use your session storage potentially. Local storage is useful for this point, and when that post fails, I'm going to add that note offline and save it to my local storage. And then, whoops, we add an event listener for online. When we go back online, we're going to loop through those notes and add them, and then clear our storage. Cool, we can load everything, add note number 6. Let's go offline, add a couple of offline notes, offline note 7, 8, etc. And now if I jump back online, you'll see these requests just got fired off and all these notes are stored online now. So I refresh, load my notes, there they are. Let's jump offline again, add a note, refresh, my offline note's still there. It's coming straight from local storage. So just need to hook into the online event and it syncs back up. So it's worth pointing out on native, offline sync can be problematic. This is really just a couple of lines of code to get that functionality. Obviously, we're hooking into the online event. There are other ways to do it. So you can potentially, well, you can have a timer or something that runs and check if you're online and then upload then. I've seen people do it every time the user navigates to a different page. We try to do a sync. So essentially, with the local storage or IndexedDB, you get the option to choose how that plays out. it's worth pointing out you don't need to post directly to your app. You can actually cache everything straight from your service worker using the IndexedDB, but I prefer to do it in the app. You can use solutions like Redux Persist and cache from the service worker. Cool, so that's pretty much it for the code demo. That's how you set up your progressive web app from scratch and how you hook into some of those service worker lifecycle events to enable offline caching and all of those awesome game-changing features. So now I'm going to talk a little bit about just the PWA ecosystem and some tools that I like to use to help me on my development. We've got Workbox, which is an awesome set of Google libraries, but they actually have a way to generate a service worker with some of these caching strategies that I talked about. So I actually ripped my diagrams directly from here, as you might see. But the great thing about this is you can have a base to start from. You can choose one of these strategies, get it to generate that, and then you can add in your own code to the service worker. So just really makes sure that every time you start a new project, you kind of have the same base code there, and you don't need to store that library yourself. And there's a lot of other good tools on Workbox. You've also got Lighthouse. So Lighthouse is a really cool Chrome extension, and also it's built directly into the Chrome DevTools. And I'll show you what that looks like. If I go over to Audits, there's the Lighthouse logo. I can generate a report about my app, and it's going to run some tests. A few things it does is just test the performance of it, but it also checks, goes down the PWA checklist and tells you if your progressive web app ready. So let's take a look here. So yeah, this site's 76 for performance, not too bad. Get a lot of metrics, and it also will tell you potentially what is taking time to load. So it looks like on this page, some of these files here, but if I scroll all the way down to PWA, it'll tell you if you're just hitting the mark with the progressive web app. And it looks like they are, apart from their start URL not responding offline. Interesting. Cool, so that's Lighthouse, and there's a Chrome extension for it as well. Also got build tools, and Create React App has a serialized build tool built in, so whenever it generates new files from your build, it serializes them, adds a little number on the end, and that means that you don't need to worry about invalidating your cache, especially while you're testing. That's a really good thing to set up, and Create React App comes with it out of the box. Also, ngrok, as I mentioned earlier, is really good. And obviously Chrome. The dev tools are awesome. You saw how much we were using them today. And there's also online icon and manifest generators. So if I just type in PWA icon generator, there's a ton. I use a different one every time, to be honest. There's so many out there. Find one that works for you. And there's some sites can even generate your manifest as well by just allowing you to fill out a form. So, yep, here we go. We could even select an image if we wanted. I think I have the PWA logo here. And I don't think I've used this site before, to be honest, but, oh, there we go. So my picture's not a square. It wants a square picture so it can resize. But usually they'll just spit out a zip file and it'll have all your images in there. Cool, so that's some of those. So yeah, hopefully now you know why you should build a progressive web app and how to figure out when to build one, when to go native, as well as how to get started with building one. And you've got some great tools. So, are there any questions? Yeah, so the question was, if someone clears the cache and you have offline data stored in there, will those changes be wiped? And unfortunately, yes. But yeah, hopefully they don't do that.
So we should use that DB.
can use the IndexedDB, and unless they clear all their browser storage, you're okay. And hopefully on iPhone we'll get access to the device storage soon. So on Android you can access the device storage directly, and hopefully with the next iOS update, Apple lets us access the device storage and store some stuff on there. So no, caches won't be shared. So the question was, will caches be shared between your native app running on the machine or device and the PWA? Caches are...
Like if you open
web
it
app.
from a web browser, for example, like you opened that web browser
Yep.
and you opened it as a standalone.
Yep, they will be, yeah. So if it's served on the same URL, your web app will share the caches with your PWA. Yeah, it just depends exactly what your cache names are and that kind of thing. Yeah. There's talk that any idea when the push notifications are going to be working was the question in iOS. So that's obviously a pretty big feature that we're all waiting for. I don't have any idea, unfortunately, but there are a couple of workarounds I've seen people rig up. I've seen someone rig up a Cordova app, which is essentially a native wrapper for your web app, and then use that to interact with the notifications. But at this point, if push notifications are a core part of your app, I'd say go native for now.
Any idea how you can track the installations? Like on a native app, you can track how many installs are there, but with PWA, can you track that?
Interesting question. So the question was, can you track your installs? Just repeating the questions for the live viewers, the people on the internet. Hey guys. So there's a few ways you could handle that. I would fire off a request when it's installed, and there's libraries you can get to generate a GUID or a unique identifier for the user's device based on their browser and a few other pieces of information that you can pull in from the browser APIs, and that's a really good way to track if different devices are installing it. That's probably what I would do.
Can we upload PWA to Play Store?
I think Google has a way to do it, but the question was, can you upload to the Play Store and I guess the App Store as well? You can't upload directly to the App Store, but at the moment, and I think Google might be working on a way to package up a PWA so you can, but I haven't done that. The worst thing about working with a progressive web app is your security issues. So it's still a web application. So any security concerns you have for a normal web app, you have for a progressive web app. And at the moment, you can't access secure storage, things like that. So depending on the nature of your app, storing a refresh token in local storage might not be good enough. It depends. So that's probably the worst thing in my opinion. And again, depending on what the user interface needs to do, making the user interface behave exactly like, behave like a native user interface without the use of libraries can be difficult, but there's a ton of good user interface libraries out there, like Material UI, for example, that I like to use to kind of bridge that gap for me. Yeah. There is my GitHub. All this code and the presentation will be uploaded to there. So I think the Brisbane one's already up there actually, but I'll put the Sydney one up in case there's any differences. Yeah, thank you everyone.